So in this video, I wanted to go over solving system of linear equations using the substitution method. Note that the substitution method is ideal when one or both of the equations has been solved for a variable. So for example, in this system of equation, the first equation is solved for y. Notice how y is by itself on one side. And how you solve using the system or using the substitution method is you're going to take that expression y equals 3x plus 5, that expression, the 3x plus 5, and you're going to substitute that expression into the second equation. All right, so let's see how that's done with another problem. So in number one, the question says solve the system by the substitution method. Well, first thing we should know that a solution to a system is an ordered pair which contains an x and a y coordinate. All right, so let's solve that. Let's figure out what the x coordinate is and what the y coordinate is using the substitution method. Notice that the second equation has been solved for y. So y is equal to 2x plus 8. We're going to take that expression y for y and we're going to substitute it in for y in the first equation. So here's how it's going to look like. So we're going to get x plus 2y, right? I'm just looking at that y. So instead of y, I'm going to plug in that expression from the second equation. So we're going to get 2x plus 8, and we're going to plug that in right there. Is equal to 6. So all I'm doing is I'm just rewriting this expression, but substituting 2x plus 8 for y. From here, what I get is I'm going to distribute the plus 2, so I'd get x 2 times 2x is plus 4x, and then 2 times plus 8 is plus 16 is equal to 6. And then I'm going to combine like terms. So x plus 4x is 5x, plus 16 is equal to 6. And I'm running out of room, so I'm going to work up here. Let me just recopy that. 5x plus 16 is equal to 6. And then subtract 16 from both sides. This zeroes out. I get 5x is equal to negative 10. Divided by 5. This becomes a 1. 1 times x is x. And x is equal to negative 2. All right. So I'm not done yet. What I just found is negative 2, the x coordinate. I then need to find the y coordinate. So how I find the y coordinate is I can go back to one of these equations. So say, for example, the second equation, and I can substitute in negative 2 for x. So here we're solving for y. So the second equation is y equals 2x. So in this case, I know I'm going to make a substitution. I know that x is equal to 2. So I get, let's see, 2 times negative 2 is negative 4 plus 8, and negative 4 plus 8 is positive 4. So here's my solution. My solution is negative 2 comma 4. And I can check that this is a solution by taking negative 2 and 4 and plugging it in for x and y in the first equation to see if it's true. And then I can do the same, plug in negative 2 and positive 4 for x and y to see if it's true for the second equation. All right. So sometimes when you're working these problems out, you're going to run into a situation where you're going to substitute, and then you're going to start manipulating it and combining like terms, and you're going to get a true equation like 8 equals 8. So it's a true equation. Anytime you run into something like that, what that means is that there is an infinite solutions. There are infinite solutions, which means this is a dependent system. The answer that you might want to give, or you can give, is x is equal to x, and the expression for y, what you can do is you can use an expression in terms of x for y. So for example, y is equal to 4x minus 4. You can take this expression for y and just plug it in or write it in for the y coordinate. Other times, when you make the substitution and you combine like terms or distribute and then combine like terms, you might run into a situation where you get a false statement, something like, after doing the substitution, you get something like 8 is equal to -9 or something like that, which is false. Anytime you run into this situation, what it's telling you is that there's no solution, which means that this is an inconsistent system. All right, so hopefully you found that helpful. If you have any questions, again, feel free to shoot me an email.